I love automation. Being able to take an idea, turn it into something you can touch and use, but having machines do the heavy lifting for you. 3D printing has become an extremely accessible manifestation of that idea. But what if you want something larger, fabricated out of wood or metal? That's where CNC or computer numerical control comes in to automate machineries like lathes and mills to follow a computer-aided design and create the physical part. A few years ago, I stumbled across a website discussing a CNC router that you could build out of steel tubing and 3D printed parts. My fascination with automated machinery and my glutton for DIY punishment screamed at me, let's give it a try. This is what we're going to be building. It's a CNC router that is constructed out of hot-rolled tube steel and 3D printed parts. At the time this video was made, the best place to get information on this project is at the PrintNC Wiki. I've also put a link in the description below the video. On that page, there's a link to the PrintNC Discord channel, and I would highly recommend accessing that resource. The written instructions to build one of these machines are incomplete and leave a lot of room for interpretation. The Discord channel helps to fill in some of those gaps. This is a complicated project, and it's also a fairly expensive project, not just due to parts and pieces, but also the tools needed to complete the build. For one, you'll need a 3D printer, and that printer needs to be capable of producing dimensionally accurate parts. Also, although not technically required, I highly recommend a drill press. Accuracy is the key to a worthwhile build, and drilling holes with a hand drill just does not cut it in my book. The more accurate you are with measurements, cuts, drilled and tapped holes, and attention to detail, the greater your chances of success. You'll need Autodesk Fusion installed to plan and complete this build. The files are available on the Discord server, and they are mandatory for everything from planning the size of your machine to being able to triple check your measurements before you cut. More on that later in the series. With all that said, let's give it a try. There are two versions of this machine: a wood cutter designed for milling primarily wood-based projects, and a metal cutter designed for, you guessed it, milling projects made out of aluminum and possibly steel. My initial goal for this machine is for wood-based projects, so I decided on the woodcutter. I need to be able to handle a 2-foot by 3-foot piece of stock, so the first thing to do is to set the appropriate size parameters in the Fusion file's parameter section. The entire model is recalculated, and the result is a version of the model with everything sized according to your custom needs. The next step is to take measurements of all the frame pieces in order to purchase the correct amount of steel. I ordered my steel online. The pieces are a bit oversized to allow me to make my own cuts and appease my own control issues. The shipping cost is not as bad as I was expecting. I've had steel delivered locally in the past, but the supplier didn't have exactly what I needed. Also, local delivery is a $90 flat fee where I am, so for a little more, I got exactly what I wanted. The total for the steel was $463. All the other hardware, the linear rails, ball screws, stepper motors, spindle, and so on need to be sourced. When I started planning this project back in September of 24, there was a site available where you could plug in the parameters of the machine you were building, and a kit would be put together with all of the parts necessary to complete the build, including fasteners. My understanding is that site no longer exists. Apparently, you now need to source all the products yourself, generally from overseas using something like AliExpress. The best place for current, updated information on sourcing parts is the PrintNC Discord. The parts package I received took about a month to be delivered and totaled $1,050. Okay, $1,500 in, and my steel has arrived. There are a couple other parameters that need to be modified in the Fusion file to ensure everything lines up. The first is the radius of the tube corners, and the Fusion file supplies 2 radius gauges. After printing them, determine which gauge best fits the radius of your steel and note it. Mine looks like 6 is the best fit. Next, measure the actual dimensions of the steel you've purchased. The Fusion file assumes 75 by 50 millimeters, but as you can see, my steel is not quite that. This piece is for the gantry. Take accurate measurements of it as well. With all the measurements taken, the appropriate lines are updated in the Fusion file's parameter list, and the model is again recalculated. Now that the model in Fusion is updated to exactly match the raw materials that you've purchased, it's time to export the construction templates. The model includes 3D printed templates that aid in marking and drilling all of the holes required for the build. On the Discord channel, a Python script is available that will export all of the 3D printable parts into a nice, neat directory structure. What a real time saver. As a final verification that everything is in sync between the virtual and real worlds, I printed out 2 guides to verify the fit. Those look great. Let's cut some steel. Accuracy is going to be your best friend throughout this entire build. With that as a goal, I highly recommend the following tools to make the cuts: layout fluid, a machinist square, a scribing tool, a measuring tape, this one marked in millimeters, a file, a metal cutting chop saw, a heat gun to speed up the drying of the layout fluid, and a 12-inch disc sander. I'll leave links to all the tools used in the description below. Starting with the 2 Y rails, I used the machinist square to check the factory edge. Surprisingly, they're quite square. If they weren't square, or at least very close, I would take a quick squaring cut on the chop saw to clean them up. I take a quick measurement to get the general idea of where the layout fluid should go. I measure the length, in this case 875 millimeters, and scribe a line using the square to ensure a line that's perpendicular to the edge. Next, I repeat the process to mark out the cuts for the 3 X-axis base tubes. I use the heat gun to help speed up the drying of the layout fluid. These get marked at 1325 millimeters. Next, it's over to the chop saw to make the cuts. Now, there are 2 types of chop saws for metal, abrasive and cutting. An abrasive saw basically grinds its way through the metal, whereas a cutting saw, well, cuts the metal. The blades for abrasive saws are much cheaper to replace, but the downside is, while cutting, they produce a fine metal dust that gets all over everything in the shop, including inside of motors, gears, bearings, electrical contacts, and so on. Even worse, when humidity rises, as it does here in Maine in the summer, all that metal dust will oxidize and corrode. The metal cutting saw, on the other hand, produces chips when cutting. These chips also fly all over the shop, but they can be corralled with some creative cutting shields made of cardboard and then vacuumed up. As a safety note, when these chips come off, they are hot. Gloves, long sleeves, and a face shield are a must. Also, don't vacuum the chips up until they've cooled off, or you'll run the risk of setting your shop vac on fire. The 3 100mm roller pieces are cut from the X base tube's offcuts. And finally, the 1351mm X Gantry is marked and prepared for cutting. With everything cut to length, I deburred the cuts using a bastard file and checked the cuts for square. Most critical are the 3 roller pieces, as out of square ends will result in binding of the ball screws when installed later down the road. The final step is to clean up the ends with a 12-inch disc sander with a 120 grit aluminum oxide cutting disc. I chose the disc sander because I could get the entire face of the tube on the cutting surface to ensure square, even cuts. The trick here is to do light, even cuts, flipping the piece to make up for any deflection in the work holding table and checking frequently with the machinist square. At this point, I'm left with 2 Y-axis beams, 3 X-axis base beams, 1 X-axis gantry, and 3 roller carriages, all cut and squared. A good day's work. This looks like a big project, but so far it's been a lot of fun. As of right now, February 2026, I'm about halfway done with this build. The next video in this series will involve drilling and tapping a lot of holes, assembling and squaring the frame of the machine, printing a lot of parts, and maybe even fixing a mistake or 3. If you're enjoying this series, please strike a like and perhaps consider subscribing to the channel. Your subscription really helps to get the video out to a wider audience, which helps me put out more content. Please leave a comment letting me know your thoughts and ideas about the video, CNC automation, or whatever's on your mind. I really enjoy interacting with you. Well, time to go drill and tap about 1,000 holes. Until next time, I'm mainejason. Get out there and give it a try. This looks like a big project, but so far it's been a lot of fun.